So moving now onto the receiver on the Jesan 88900, it actually sounds pretty abysmal. The signal generator at the moment is, I'll just give you some figures. It's on, that's 10 microvolts. It sounds noisy, and to be honest it sounds off frequency, which it could easily be. Now remember I told you earlier that the transmitter and receiver sets up separately. You set the 10.24 first, and then you set the, was it, which way around was it? The transmit using that trimmer, and then you bring it on frequency on receive with this one using a, we'd have to use a marker oscillator, which in effect is another signal generator set to 10.695 or 455 kilohertz. What I'm going to do first though, I suspect the detector's out, and I think that's part of why it sounds pretty abysmal. Well, the detector on this radio, I'll just zoom in. So we need a really strong signal off the signal generator, so I'm putting that up really high. Looking at it on the oscilloscope, we're going to peak it, just going a bit more so you can just see that. Because it's underneath the wiring harness. You've got the IF subsystem chip just there, and that is going to be the detector. So if we alter that, hopefully it'll come in better. It does indeed. That's actually made a huge difference as I look at it here on the oscilloscope. I'm looking for maximum audio, maximum recovered audio from that. Now that is 3 microvolts. If you remember, the best we could hear really before was 10, which is there. So that's made a colossal improvement already. Well, the next thing I'm going to do is set up the marker oscillator, and it's a bit of a faff, so I'll just have to pause the video while I do that. Right, with the marker oscillator on, I'm holding the output of that from the wire that comes out on in the vicinity of the IF circuit. We get a bit of a musical note. It's very difficult to hear this. I then adjust the trimmer, which is 2 on 2. Try and move my sleeve out of the way. And that is it. Just to nullify the musical note which was just discernible. That is now on frequency. So we'll put the tone back on the signal generator. Now that's 3 microvolts. Listen to how much more crisp that is to when we started, which was at 10. Now, I'm going to turn the signal generator down to 1 microvolt. Now the radio should perform better than that. That is, I'll tell you what we're looking at. 2 and a bit microvolts there. So now what we're going to do is align the receiver. And this is one of these semi-guesswork jobs. It's always the case when you've got unusual sets like this. So clearly we're going to be on these here. So I've got a cyanide meter here, and I'm looking for the maximum possible performance on the receiver with these. That's a colossal improvement already. I mean, you can even hear that without looking at meters. I can back off the signal generator now. In fact, we need to go on the next range. So that's the 1 microvolt range. Go through them again. Sorry, that wasn't clear which ones I'm doing. We're going through these. And that looks about as good as we are going to get. Now we'll see how that reads. That is 0.6 of a microvolt. I would like it to receive a bit better than that. So I'm going to go through it yet again. Well, that seems to be the maximum sensitivity we can get out of it. It's about 0.6. I'd like them to go down to about 0.3. Just pause the video, see if we can get any improvement. Okay, so that's the best we can get on it, which is 0.6 of a microvolt. I say it's not a good example necessarily, but that's as far as it's going to go. It isn't faulty, but it isn't brilliant. Right, what we're going to do is set S9, and to do that we need to put a 100 microvolt signal on the signal generator, which I've now done. We'll see what that reads on the S meter. So that should now read S9. Well, as you can see from the meter, it reads S3. So we just need to bring that up, and it's the second of the presets up from the bottom there for the S meter. So just put the tool in there, and we'll set that now for S9. Well, it's supposed to be that one. I'm so upset. Here we go. Egg on one's face. It turns out I was lying to you earlier. The first of those presets is the S meter, and the second one is the RF meter. So I got that wrong. So when you're setting up the transmitter, it's the second one, which is just the RF meter. I'll just go and prove that, and we're now getting the 4 watts on transmit. And then on receive, I will just now align that. Nowhere near where we want it to be. So what is S9? Well, on these sets, the most you can S9 is 300 microvolts, and plus 30 is 1 volt. Well, that's not the normal way it's aligned, but that's how these sets are. So we've set that to maximum. So it's what you'd call a lazy needle, but we don't modify radios, that's how it is. And so that has set the S meter. So that's slightly disappointing receive. So that's 1 microvolt, 0.8, 0.7, 0.6, just about discernible to 0.5. There are other presets here, and the next one we're going to do is a squelch. So to do the squelch, we'll put an S9 signal on, what I call an S9 signal, which is 100 microvolts. We'll better put an S9 signal of what Jesan are expecting. And we're going to turn the squelch to full, and that should of course come through. So we're going to just drop the signal generator. That's now to 100 microvolts, which is our S9 and their S3, and the squelch has come in. Okay, go over to their S9 and it comes in. That's ideal. Now turn the signal generator right down. In fact, we'll turn it off. Set the squelch to the threshold. Advance the signal generator. And it comes in at 3 microvolts. That's fine. That tracks very well. However, if it doesn't, The preset for that is the second one up there. You've got the clump of 3. The first one we said is deviation for transmit. The second one is the squelch preset. And presumably the third one is for the selective calling system. Now, these radios are equipped with a socket on the back for the matching selective calling unit. Because we don't have that, we're not going to make any adjustments or upset it for those people who do. So that concludes it. That's the Jesan 88900. It's now doing 4 watts. It's receiving at 0.6 microvolts. I'd like it to receive it a bit better, but that's how this is, and there we go. We'll get it back to the customer.